Okay, so we're going to do day 2 of our z-scores. And if you look at the second worksheet, I've already started you out with the model to get us ahead here. So we're looking at SAT scores, kind of an interesting topic for what's going on right now. But most of you took SAT last year. So if we looked at the 2017 distribution of SAT scores, the mean for that year was 1100, and which means the average person got 1100 on the test and the standard deviation was 150. So if we look at this distribution here, starting with our raw scores, 1100 would be our center score. Moving 1, 2, 3 standard deviations to the right would be 1250, 1400, and 1550. And then moving 3 standard deviations to the left would be 950, 800, and 650. Reviewing the empirical rules, 68% of students would score between 950 and 1250. 95% of students would score between 800 and 1400. And 99.7, which means almost everybody in the country had a score somewhere between 650 and 1550. Okay, so that's kind of a review of everything we've gone. We also talked about z-scores. You could talk about your score in terms of a z-score. If you had a z-score of 0, you had an 1100. If you had a z-score of 2, you had a 1400. If you had a z-score of negative 1.5, you had somewhere between an 800 and a 950. We also learned how to use the calculator, and we're going to review that today using our normal CDF function. So for this first one, it's what's the probability that a student scored below 1200? So we want to know what's the probability that x is less than 1200. And so that's going to be our normal CDF. And we're going to start at 0 all the way up to 1200. Those are all the possibilities. You can't get a 0 on the SAT, but we'll go all the way down to 0. So the mean is 1100. Standard deviation is 150. If you wanted to look at this in terms of a picture, 1200 is going to be somewhere around right here. We want to know everything to the left. So that's going to be a percentage over 50%. Let's go to our calculator. So again, second vars, normal CDF. We're going to start at 0. We want to know what's the probability that they got 1200 or less. Do it again, 0 vars. From 0 to 1200, and the mean was 1100, and the standard deviation was 150. So that probability came out to be 0.7475. There we go. For some reason it takes a minute to get back after using the calculator if I'm recording. 74.75% probability that you scored 1200 or less. What's the probability a student scored above 1000? So again, we'd use the same idea. X is greater than 1000. Except in this case, we want to go from 1000 to the highest score. So 1000, and in this case, up to 1600. And our mean is 1100, and our standard deviation is 150. We're not always going to know what the end limit is. Later, I'll show you how to. Technically, a normal distribution goes on forever. So we would use infinity, but it's enough that we know what the highest score is, so we can just put that in there. So 1000, 1600. So again, we'll go back. This is what we call a right-tailed test. 1000. And we're going to go up to the highest score. And then 1100, and the mean is 150. The standard deviation is 150. So 0.747, it's almost the same probability. The probability that my app is going to come back on, we'll see. Here we go. 0.74. 0.74. So we'll just say 74%. Almost the same probability. All right. What's the probability they fell between those two scores? So if you remember from the previous video, that was the probability that X was between 1,000 and 1,200. I'm going to use an abbreviation here, NCDF. And it's going to be between 1,000 and 1,200, mean of 1,100, and a standard deviation of 150. Let's hope our calculator does not lag this time. So we're going to go between 1,000 up to 1,200. And my mean is 1,100. And my standard deviation is 150. Nice thing is the calculator saves everything up above so you can see what you did before. And it gives me 0.495, which is a 4% chance of that happening. This is interesting. My iPad has never lagged like this. Maybe it's because I'm recording. So that comes out to be 0.495, which is a 49.5% chance. Right. So we're going to review a couple other things. University requires applicants to score in the top 10% on the SAT. What score would they need to qualify? So again, to score in the top 10%, you would have to score in the 90th percentile, or you would have to score better than 90% of people in the country. So we're going to use the 90% in the inverse normal function. And our inverse normal, we put in 0.9, and then we put in our mean and our standard deviation. And that's going to give us the score you need to be in the top 10%. So second bars, oops, inverse normal. We're going to do 0.9, and the mean is 1,100, and the standard deviation is 150. So 1292.23. 1292.23. So you would need a score of 1,292 points, more or less, to be in the top 10%. It's not too bad. And let's just do a couple more conversions. What z-score would apply to 900? Remember, to get a z-score, you just take the score minus the mean. So in this case, the mean is 1,100. So you're below average. So you're going to get a negative z-score divided by 150. And in this case, this looks like it's negative 200 divided by 150. So negative 200 divided by 150. Looks like it's negative 1 1/3, so it's negative 1.3. Negative 1.3, so you'd have a z-score of negative 1.3. And then is a z-score of 1.5 good on the SAT? It absolutely is, because if you look at this, that means you must have scored somewhere between 1,250 and 1,400. So a z-score is definitely good if you're above average. So we would say Yes. Yes. Since it is 1.5 standard deviations above the mean. Okay, so we are done now with section 7.2. Again, I apologize for getting these to you so late. You can go back and take the quizzes late now. And if you need help getting a calculator online, just shoot me a message on Schoology and I'll help get you that link. The TI-84 link is in the update section. And you could also get the calculator that I've been using in this video if you need it. All right. The next videos are going to be on this week's work, which is 7.3 and 7.5, but a lot of it is repetitive because we're going to be using the same calculator, the same model. Um, um, Actually, it's going to be exactly the same skills. We're just going to introduce a new theorem called central limit theorem, which says if the sample is large enough, then we can call it a normal distribution. So far, we've been calling things normal, and it allows us to use this model. But if we don't know it's normal, it has to be over 30. All right, thank you.